my background is kind of software development. And I'm sort of in the process of trying to become an artist. I'm a programmer, traditionally, but not a functional programmer. I've got to admit, I'm quite new to functional programming. I've been writing an awful lot of this could. Right, so as I say, I'm trying to become an artist from a software background, and my particular interest is in software to make things. So I kind of got interested by the new technologies that are appearing, like 3D printing, laser cutting for fabricating, and I'm kind of interested in how you can define those things with software. And I did some work on that before I really started playing functional programming, where by my evolution I got into processing, and I was writing Java in processing, and I made, for example, some pieces of more machinery. They're sort of small interlocking collections of wheels and things like that are laser cut. That this is like a little fractal algorithm. It's sort of, you start off with a big wheel and then it generates branches and you can do some. But I'm not going to talk about that because that's not actually functional. So the latest stuff I've been doing is using Clojure and Quil, which is a wraparound processing. I congratulate you. I've released a party now, is that right? Which is very nice. And I'm kind of starting to explore. So my interests are several things. My interests artistically are in the kind of relationship between craft practice and software development. There's a sort of discourse today about programming being a kind of craft, and I'm sort of interested in this 19th century discourse around craft, the arts and crafts movement, and the idea of craft as a sort of better way of working, which I think ties up with, let's say, some concerns of people in functional programming today, who's like, why can't we use the languages we'd really like to use? You know, we'd like tools that empower us rather than tools which kind of force us into these institutions, let's say, Java as a language which is designed to put people in institutions, right? And there's a sort of parallel between that kind of discourse and the arts and crafts movement in the mid to late 19th century, who were looking for work which was kind of done by handmade or high quality, not sort of working in factories. So a lot of my artistic practice is sort of in this area, but of course those people worked a lot with really more, they work with wallpaper design, they work with textile designs. So I'm kind of interested in, partly as well because the technology, you can get access to embroidering machines and things like this sort of more easily actually than where I live. It's not so easy to get 3D printing and laser cutting. So I started working with this, right? This is my medium at the moment. I used to be I am also a member of a laptop orchestra, so I am a kind of electronic musician as well. And I'm really glad I didn't propose an electronic music talk today because it would have been just more of the same. So I kind of did this, but then, you know, there's also a tradition of like successful musicians becoming fashion designers, and you just pass these around. And I just figured, well, you know, why not just jump that stage of needing to be a successful musician. And just fashion design. So here's a few. All of these are designs made with Lisp programs. So this is that's a phone case as well. So all the things I'm passing around are outputs from this. What is this? This is patterning. It's a Clojure system. I'm very new to this. I'm not a live coder at all, so I apologise. It's going to be slight slow live coding. But here, as you can see, is a definition of a pattern. Here's a standard function for my library called poly. You give it a center coordinate, you give it a length of a side, and you give it a number of sides, and you give it some stroke information, and it will give you that, right? That's a great pentagon. Let's just define a couple more, color a little bit more in sort of reusable ways. Let's have, I don't know, 200. Let's define a colour like this, a bluish colour, and let's define a fill version of the colour. Let's have 200, 150, 255, and we'll make that slightly transparent. And now we can say over here, let's have the stroke, the cull, and let's have the fill colour, the cull F.
Is there any way to make the font a little bigger?
If anybody knows in Emacs how to do that quickly, if it's in your fingers, yeah, please do. I honestly, I'm new to functional programming. I started writing Clojure 3 or 4 months ago, and it's only when I started writing Clojure 3 or 4 months ago I went back to using Emacs because I wanted to parrot it, which is wonderful.
Under tools, set optional font.
Sorry?
Under tools, I think.
Options font, yeah.
Set optional font will be under the bullet menu.
Control plus.
No, control plus word. Not in.
No, you're yeah. Terrible method.
You had the context menu.
Can we just sort of pull the projector back?
Tools, yes. No, it's not there. It's on mine.
Just options, maybe?
Here we go. It's shift flip.
Ah.
Wait.
Okay, that's great. So is that good for everyone now?
Yes. Excellent.
Maybe one down. Maybe take it down one. Oh.
Piece of art.
Great. Thanks.
Right. So now I have to remember to execute all this stuff. Execute that. Execute that. Execute that. And okay, so we now got this. Polygon slightly more thing. I'm just going to give it a stroke weight 4. Give it a thicker boundary. Right, okay, so that's pretty self-explanatory. But now suppose, well, the next thing we can do, so patterns in text often, they're all about sort of basic figures, and then they're about laying it out in some way and repeating it. And what are the sort of forms for repeating it? So a simple form we've got here is something like, so patterning's got a layouts library. I've got a thing called clock rotate. Clock rotate is okay, that just turns it around. That's not very exciting. But if we were to move it away from the center, let's move it, make it a bit smaller, move it out from the center, do it again. Now you see you can make 5 of them. Okay, so let's make a little function to do that. Let's make a function which makes a round of sort of several things that have a certain number of sides. We'll make the number of sides and the number of things together equal, so we'll take an argument. We will grab that. And so we'll now use this round 9 here. So do that, try to do that. Oh, that's fine. I told you I'm not a large coder. Right, here we go. So we've got 9 in place now.
Projectors.
Yeah, I think cool. Okay, so just to keep talking while. Oh God, sorry.
I can ask you a question.
Yeah, ask a question. Please ask me some questions, and I will get back to the actual demonstration.
So you mentioned Quil, which is on top of processing.
Yeah.
And processing is Java-based.
Yeah.
And at my university, we got rid of Java by bringing in a scheme-like language.
Sure.
And because Java is doing horrible things to students.
Yeah.
And now for the non-majors from the Faculty of Arts, they're starting to use processing with them.
Yeah.
And it's exposing Java to them.
I know, it's terrible.
So is there some way we can get rid of processing completely and
Also,
offer?
Quil sits on top of processing.
Yeah, but it's
And you don't need to look at the Java at all. If it's underneath, that's fine. It's like with C and Haskell, right? It's not a problem. So you just need to...
You're completely hide.
Yeah, absolutely, completely hide. It gives you multiple advantages. So with processing, you write Sketch, and then you would press the play button, and it would compile it and show the visuals.
Right.
With Quil, because you're encoding, you can hot swap the code. So you can run the visuals, you can modify the function on the fly, and change the visuals.
So I can sell this
So
as
you
a better
give-
version.
Absolutely, right.
Good, thank you.
Yeah, I mean, I've been a Java hater for the last 15 years since I was kind of forced to work with it. When I was considering what languages to work with for this, so I'd done a bit of processing because I did a master's in digital arts, and that's what they all do. And I mean, processing makes Java more civilized than it would otherwise be.
Yeah.
Right? There's no question about that. That helps. But because it's a preprocessor that hides some of the stuff from it.
To continue, I mean, I have also used processing quite a lot, and I think one of the main problems with processing is it relies quite a lot on local states. And you don't, of course, need that. You would like to hide it behind some kind of functional abstraction.
In fact, I mean, I started with processing because I wanted to have this kind of easy way of generating stuff. But actually, the patterning library, which is the library I've created, it will also spit out an SVG file. So it's perfectly...
Can you increase the font size again? I'm serious.
It was
Shift left click.
Cool. Shift left.
Shift left click.
Cool.
Great.
Is that good?
Yeah. Thank you.
Have I... No, not yet. Is my cider working? The cider is the connection between Emacs and Clojure. Okay, so let me just put my colours in again. So yeah, certainly using patterning, I try to avoid as much state as possible. Everything is just functions and functions, functions, and it's only at the end that I sort of have to get involved in any I/O that blasts it out. So I just spit out an SVG file. I have a version that can be called from JavaScript. So Clojure can compile both into Java and to JavaScript, and I have a version that will run in the browser as well. And
Can I ask a question in the meantime?
sure, ask a question, please.
So since we're talking about state, is it ever annoying that in 2D the order of the drawing matters when in 3D doesn't?
Sorry, say that again?
That the order in which you draw stuff in 2D matters. Is it ever kind of annoying for any kind of reason?
Yeah, right now, this whole thing has the effect of it, when you start putting multiple patterns together, it will start sort of drawing from the top to the bottom. So you'll end up with something that's almost like one of these sort of fish scale things, the things at the top kind of or the bottom overwrite things at the top. The new version I'm going to produce very soon is going to have an explicit Z ordering of some of the components. So you can actually then force it in. That's not here in the library yet, but it's one of my things I want to add to the library. Yeah, I've got that right. Okay, put that in. Okay, so there we have it. Now we can keep on. The important point about the library is that you can build a pattern. Every time you build a pattern, you get the same type of thing out again, so you can keep on repeating, keep on mounting them up. So we have another layout which puts these into a grid. So we'll just add that grid layout over there. I'm trying to decouple or make a sort of fairly loose coupling between the laying out of things and the things you put in. So when it comes to a grid, what you do, a grid is a layout which creates a number of positions, and then you send it a list, which could be an infinite lazy list, of things to fill those positions. So if I have to just do a repeat around the thing I'm passing in here. So now you can see we've got an 8x8 grid of this pattern. And that's good. Okay, so we can start repeating things now. Now we can start doing some interesting tricks here. Instead of doing a repeat, we could do a cycle of two different things, and then we could get some interspersing between them. Now that looks really good because that's kind of nice and checkered, but actually it's starting to count downwards, 1, 2, 3, 4. And if you made that an even number rather than an odd number, then you'd see they'd all just line up, which isn't so interesting. So we can have an explicit checked layouts, and here we'll actually pass it to...
This spelled checked.
I have, but actually that's the way it is in my... oh, no, sorry, no. Okay, so now we can have our. So even more interestingly, you can do. I'll show you one last trick. So this is. I'm trying to kind of take advantage as much as possible of the kind of functional toolkit that's available. So what I can try doing, for example, is instead of in my grid, I could generate that list with, say, a map. So I take a mapping between this function round and let's say a list 3, 4, 5, 6, which is going to give me 3-sided, 4-sided, 5-sided, 6-sided. Okay, that's going to give me where I've got a cycle path. So where are we now? We've got a cycle. Right, that's giving me that. If we don't make it quite so even, then you can start building up these more complex patterns. There's a lot more to it. The library has got L systems built in, so there's functions for doing. I don't have time to do this stuff, but I can write an L system that you iterate several times, and you can generate much more complex sequences of patterns that need to build up. I've got a turtle, so for things that are less easily, less regular, not just made out of regular polygons, you can draw them. So as you see on the thing I passed around, there's an L system generated tree that's been drawn. The turtle's got recursion, you can kind of branch off and then come back again. And yeah, I do apologise for the technical hitch. Any other questions or about the general approach or about?
Yeah, we still have some questions. Some more questions to
Hello? Sorry, yeah.
So I mean, obviously at the moment you're interested primarily in making things and sort of the embroidery, potentially 3D printing. Have you thought of doing any sort of animation with this at all? Or is it?
I've thought of it, but I've sort of kept my focus on the thing. I mean, this is a kind of basic, there's a sort of core level of this library that could do lots of things. And here we're obviously looking at something that's a little bit nicer on the screen. But for the embroidery machines, obviously it just generates, there's no fills, there's all just, if you're going to laser cut stuff, it once again be very much sort of vector type patterns. You could use this in animation. I've thought of doing some experiments, because obviously processing itself has got animation, very easily. You just have to put them in the drawer. It's actually being drawn down here, in the drawer, which is the standard. So if I had some state, and I just changed the state every time, this would be different. But that's not a direction I've been exploring because my focus is very much on the stuff and on the, where I'm going with this is, as I showed you in that picture previously, I have had things generating mechanical parts, or they're not very useful mechanical parts, they're more for demonstration purposes. But, so look, we're moving into a world where we're going to have 3D printed, we're going to have fabrication of that kind. Now, normally when stuff gets made, fabricated, you, different plates or different machines, you fabricate components, and then later on you come and you assemble the components and sub-assemblies into a final thing. So one factory will make millions of this kind of cogwheel or millions of something else. With 3D printing, you make all the parts in place. So that kind of gives us a whole new way of sort of challenge for designing, because actually you need to assemble all the parts together into your model so that then the 3D printer just goes off and prints it. And so that's why I think this approach, although I'm showing you something very, very decorative at this point, is interesting, because we kind of, in a sense, we turn the standard manufacturing process upside down. We stop having lots of separate making and putting it all together at the end. We make the whole thing. The design. We have to design all of it in place. We have to design exactly with this hierarchy of things inside things inside things. And to me, it seems quite obvious that at some point we are going to be doing that all in software. And we will want to assemble those hierarchies of components and components. And then, languages like Lisp are nothing but textual representations of things inside things inside things inside things. So that's the kind of parallels that I'm exploring. But I'm an artist. I'm sort of trying to be an artist. So I'm also exploring them, but I'm not, very committed. I don't have much responsibility to make practical things yet. But I think at some point in the future we'll start thinking of things in this way. Thank you very much. Sorry again for that.
I have one quick question to follow on from that. Do you think that also, I'm guessing that there will be lots of design rules for being able to manufacture things in the 3D printers. So they also be sort of checked?
I think eventually we'll move something almost like HTML with CSS and with like a cascading style sheets. Because I mean, eventually what you want is you want to be able to declare a kind of basic body plan or something. And then you want to kind of add supplementary constraints, design constraints on top of it. And HTML with CSS in one sense, for its faults, is a sort of model of how you separate the logical structure of something and the ultimate details about where everything goes and how it looks. And I assume that what will happen is we'll end up with languages that are designed for declaring the structure, and then we'll give styling hints, which are basically constraint rules, over and above that. And perhaps there'll be separate languages, or there'll be, domain-specific languages for doing that.
Okay. Let's thank Phil again.